All right, so round two was more of a conceptual look at distance in displacement. Round three is going to be a little bit more formula-like, looking at displacement in particular, right? And then we'll do a couple problems at the end to help hammer home that difference between displacement and distance. So just kind of at the start, some vocabulary, symbols. Remember that from, we talked about units, conversions, algebra trig, right? Talking in the physics language, seeing the symbols, right? So often in physics, we talk about the change in position. And instead of having to write that all the time, we have symbols that represent change in, and then the next symbol after that would be the change in like a position, a change in velocity, a change in acceleration, a change in momentum, a change in energy, right? We talk a lot about change in physics. Things change, right? So that symbol for change is that delta, the triangle. So we see this means change in, this means position. You put them together, and what do you get? Not bippity boppity boo, but you just change in position, right? Delta x. When I say delta x, I am saying change in position. When I write delta x, I mean change in position between your initial and final, your start and your end, your beginning and your finish, right? Your 1 and your 2, okay? So when we calculate this displacement, that straight line distance between x1 and x2, where we use this formula right there. So delta x means in the language change in position, but from a calculation quantity mathematical operation, when you calculate the change in, you take the final position minus the initial position, right? So there's a lot going on here, guys, right? What do these symbols mean, right? They have a meaning to them in regards to what's happening from the physical space, right? Boom, boom. There is a position 1, a position 2. There is a change in position from 1 to 2, right? That's what we're talking about. How do I do that? I ended at position 108 centimeters. I started at, 58 centimeters, right? So there is a difference from 58 to 108 centimeters. What is that difference? That's your displacement, that straight line distance. From here to there. What's the difference? 108 centimeters minus 58 centimeters is 50 centimeters. That's that change in position. It's literally now a number. That number has a physical meaning. All right, maybe I've said enough to seem like I'm talking in circles. Hopefully not. Let's keep going and do some more problems. First one I'll do. Second one, I'll let you try on your own, right? So we're going to calculate the displacement of swimmer A, just as we had up above, if the length of the pool is 50 meters. So now's a good time to start. We're going to start practicing drawing these pictures, even though I know you could do this in your mind probably, but when we go to the next question and then the next question, things are going to change, right? And if we draw our picture, we'll have a systematic way of continuing to calculate this change in position. Here we go. Let's first things first. Let's draw coordinate system. All right, coordinate axis goes like so. There's my positive x. I'm going to make my origin at the start right here. X equals 0. Now, let's get the locations, right? I want to know, calculate the displacement of the swimmer if the pool is 50 meters. So I start at the start, I end at the end. So right here, this is where I have my position x1. Here is my position x2, moving at constant velocity still. So I will, just to have a nice complete picture, have my velocities drawn right there, v1, v2. If I wanted to, I could also say, hey, you know what, on that coordinate axis, this right there is where my position x2 is equal. If I were to put an actual number to that, right, what would that be? Length of the pool is 50 meters, so the position x2 is literally 50 meters. Okay, so this is my picture. From the picture, we start to apply that to my calculation. Delta x is equal to x2 minus x1. From my picture, I can see x2 is at 50 meters, so my delta x, my displacement, is 50 meters minus x1, which is 0 meters, or 0. That means my delta x in this case is 50 meters, right? Duh, Dr. A. Great. I hope you keep having that reaction to all the other problems we go through, guys, right? But building good habits, you gotta start crawling before you can start walking and running. All right, number 2, we have calculate the displacement of swimmer B if the length of the pool is 50 meters. We're going to use the same origin as number 1, but you need to pay attention to where swimmer B starts and finishes. Give it a try. Press yes when you're ready to, well, actually, give it a try. Hopefully, check the correct answer, and then I'll run through it. All right, same coordinate axis as up above. I'm going to run through this a little bit faster now. Plus x, there's x equals 0. Over here is still 50 meters. Only now, swimmer B, I'll make a different color. I'll do red. All right, there's swimmer B. Right there and there. Only now, this is position x1. This is position x2. And then I'll draw my velocity vectors in here as well. All right, velocity, now you're moving to the left. Moving to the left. Here's V2. Here's V1, still moving at a constant velocity. Right? Now if I wanted to calculate this, right, let's do a calculation right there. So my delta x, the formula for delta x is still the same. x2 minus x1. Only now, my x2 is 0. That's where you end. You end at the finish, and I start at 50 meters. And so my delta x now is negative 50 meters. One other thing that I could add to this, right, if I wanted to draw that actual straight line distance, right, I have my dot x1, I have my dot x2, just like the round up above, I can draw a straight line distance between the two, and I get a delta x. Same thing I can do up above, only I start at x1 and I end at x2. So this is also a delta x, right? Now we notice that, well, I guess let's go run through the question here. What's the difference between the two displacements? Let's see. They're both 50 meters, but one is positive, the other is negative. So the difference between the two is one is positive, the other negative, right? That's the difference. Physical meaning for this difference between the two, what would you guess? Right? Physical meaning, look at that arrow, right? The violet for swimmer A, the arrow's pointing to the right, which is in the positive direction. Let's get that spotlight, right? My arrow is pointing to the right. It's in the same direction as I've said is positive. Look down here for swimmer B, the brown arrow points to the left, which is in the opposite direction. So if I wanted to complete my little coordinate axis, I would say anything that points in this direction is going in the negative x direction. Hence the brown vector is negative and the violet purple one is positive. Right? So the physical reason for the difference between the two is the direction of travel. Direction of travel. Right? Okay. So what would happen to the answers for swimmer A and B if the positive direction were the opposite way, right? It's typical convention to the right is positive, up is positive. Doesn't always have to be so, but let's just think. What would happen if I swap the direction, then A would be negative and then B would be positive. The arrows stay the same, right? That violet arrow would still point to the right. The only thing that would be different, I'm just going to draw this, right? Don't change that out, right? Is this would be the positive direction and this would be the negative direction, right? The coordinate axis is not something that's just there in space. It's not a physical thing. It is an analysis tool. The picture x1, x2, and x1, x2 The velocities and those displacements, those are physical quantities. It's there in space, right? That vector will not change whether or not I have a coordinate axis which to the right is positive or the coordinate axis to the right is negative. Okay, that vector will not change. The displacement will not change. And actually the number won't either. It will always be 50 meters. But one will be negative, one will be positive, indicating the direction that the displacement has taken place. All right, if you need to rewind that to take it in again, do it. We're going to continue to move forward because you can rewind and listen again if you need to. How about this one? Give it a try. What do you think? This is just a guess here. Actually, no, there's probably going to be a right answer or a wrong answer. I can't remember. But what would happen if you move the origin to the center of the pool, right? Take a guess. Now that you've done that, actually calculate the darned thing. And when you've given it a try, right, that's really important. Give it a try. Go ahead. So what are you doing, right? Swimmer A, move the origin to the center. Maybe I'll just draw that for you really quick. Right? All right. So there we go. There's that. Now your origin is right here. There's x equals 0. Okay, now at this point, give it a try. Okay, maybe you came up with it, maybe you didn't. Let's see. Start, finish. All right, there's x1, there's x2. Sorry, no fancy colors this time. There's v1, there's v2. Now just looking at this from straight up picture diagram, has that delta x changed? Has that delta x changed in regards to its direction? Is it still positive or has it become negative? Well, looks like it's still positive to me. Has the length of that changed? Doesn't appear to. So everything here kind of points to everything being the same. But let's actually roll through this. Delta x is equal to x2 minus x1. What are the values for this x2? What's the value right here? Remember, the length of the pool is always going to be 50 meters. So your actual position at x2 is now, hopefully you got it, 25 meters. My position x1 is going to be, if you said 25, you're so close, but you're not right. It's negative 25 meters because you're on the left side of that number line, right? Negative position. Completely valid to have a negative position. Okay, so I have x2 is 25 meters minus a negative 25 meters because that's position x1. Remember, when you do this, you get to add the opposite, right? So my delta x is 25 meters plus 25 meters, which is a positive 50 meters. So did the displacement of swimmer A change? No, it didn't, right? So the displacement of an object is it independent or dependent on the origin? It is independent of the origin. All right, so we're going to summarize distance and displacement here. 1, distance is a scalar. It's just a number. It's what's on your odometer on your car, right? You travel that way, it tells you you've gone so many miles, right? It's just a number. We call that magnitude. With displacement, though, is not just a number. It has a number. It's a magnitude, right? That's the 50, right? So the number, we have a special name. We call it magnitude. But the displacement also has a direction, okay? So distance, scalar, number, magnitude. That's it. It's on your odometer. The displacement is a vector, though. So it doesn't continue to just add, right? Sometimes it can subtract. Sometimes they add. Depends if they're in the same direction or opposite directions, right? So it has a number and a direction. In that direction, we indicate with positive or negative. So distance continually adds up. Displacement only cares about start and finish. Where did you start? Where did you end? Right? So if we want to talk about that specifically between 2 different points, eventually we'll talk about adding or subtracting these vectors, right? Displacement is independent of origin. right? Which is good. This is a good thing for physics. It means everyone sees the exact same physical thing happening. We'll all see the same displacement, no matter what point of reference we choose, right? On a bigger scale, all physics is independent of choice of origin. And that actually has some pretty big ramifications for upper division physics, which we won't get into now. But that's the end of round 3, everyone. Was it a doozy? I hope it wasn't a doozy, right? Because we got some more physics coming. All right, here we go. Round 3 problems. Jumped the gun in that last video, so we'll see if we can merge these guys together. So, if not, you just got a couple different videos. Person starts in Boulder, drives to Denver, 50 kilometers away. Does that in an hour, stays in Denver an hour, speeds back to Boulder in 30 minutes. Question we have here is the distance traveled in the displacement of the person for the trip to Denver. So we're just going from not start to finish, but we're going from start to Denver for right now. So assume straight line travel, picture's offset. What do you get for this one? Now for here, again, this right there, distance, first column, displacement, second column right there. Give it a try. All right, right here, everything's moving in straight lines, so you should end up with distance to Denver is 50 kilometers. Displacement to Denver is also 50 kilometers. Well done. Second one here. Person starts in Boulder, drives to Denver, 50 kilometers away, does it in an hour, stays in Denver an hour, speeds back to Boulder in 30 minutes. Distance, travel, and displacement of the person round trip are, give it a try. Well, round trip. Let's see, we go this way 50 kilometers, go back 50 kilometers. That to me, 50 plus 50 is going to be 100. All right, well, that means C can't be an answer. Now let's think about this. If my x1, right, how do I calculate delta x? It's equal to x2 minus x1, right? So I can think about this formula-wise, or I could think of, here's x1, right? After I go this way and I go back, well, what's x2? x2 is exactly where I started. So x2 and x1 are the same location. So we have x2 equals x1. So if x2 equals x1, then I end up with x1 minus x1. It's the same thing minus the same thing, right? It's the same location versus the same location, right? If I started at Boulder, which is, I don't even know what numbers to say in here, guys. You guys just like, Dr. Ray, they're just numbers, right? Guys, it's just letters, okay? Just letters here, right? x1 and x1, right? Means I started and I ended at the same location. So my displacement here is actually, if it's going to write it, 0, right? So if you wake up in your bed and sleep in your own bed that day, your displacement's been 0, right? Because you start and you end in the exact same place. So the answer here is going to be B.